Every chemical bond is a tug of war between two atoms, fighting over the same pair of electrons. And there's one number that tells you who wins. It's called electronegativity. And once you understand it, you can predict almost any bond on the periodic table. Okay, so electronegativity is how hard an atom pulls on the electrons it's sharing with another atom. That's it. And what makes the pull strong? The same two things that decide atom size. A small atom. Bonding electrons sit close to the nucleus. A high nuclear charge, more protons yanking. Small and packed with protons means the top right of the table. So that's where electronegativity lives. Fluorine sits at the top. Pauling scale value 4.0, the greediest atom in the whole table. Cesium, bottom left, sits at 0.79, practically gives its electrons away. Now, look at what happens when you pair two atoms together. It's not the values that matter, it's the difference between them. Two atoms with the same electronegativity, they share the electrons evenly, a clean, even split. That's a pure covalent bond, like two hydrogens. Small difference. One atom pulls a bit harder. The electrons sit closer to it. The bond is lopsided. That's polar covalent, like water. Oxygen hogs hydrogen, lets it. Big difference. Over about 1.7, and one atom just takes the electron. Full transfer. That's an ionic bond, like sodium and chlorine. And here's the thing, they don't tell you in class. There's no real line between ionic and covalent. It's a slider. One number, the difference in electronegativity, quietly decides where each bond sits on that slider. Every bond, every molecule. And what does it actually measure? Not something you can stick a meter into. Pauling worked it out from bond energies, how much extra stability you get when two different atoms bond versus when they bond to themselves. Electronegativity is basically a proxy for that imbalance, a number that says this atom is greedier than that one. So that single value on the periodic table isn't just trivia. It tells you whether a bond shares, leans, or breaks all the way to ionic. Top right, greedy. Bottom left, generous. And everything in between is just chemistry happening on a sliding scale.